Folks, welcome back. We're going to get underway. And our first speaker for this session on commercial off-Earth resources is very appropriately from Planetary Resources, one of the pioneering companies in this space. And I think Planetary Resources also has been a great supporter of this conference down through the years. So it gives me great pleasure to invite Ben Baseley-Walker to the podium for your presentation. Thank you.
Director for Global Affairs for Europe, Middle East and Africa, also Australia and China. I must make a caveat before I start. I'm not a scientist, I'm a lawyer, so apologies. What I'm going to do today is to run through a little bit of kind of how we see the world. The difference perhaps between this being an academic scientific conversation and the realities of what happens when you overlay a business case and a commercialization aspect to this endeavor. So I'm going to talk about asteroid mining, company overview, a little bit on kind of what lessons and what realities we have encountered from the traditional mining sector, and what works and what doesn't conceptually. A little bit about space resources value chain, like where do we fit, where do we see others fitting, how does this business evolve in the coming years, and then lastly a little bit about what the international policy context looks like. So I think to start off with, Planetary Resources, we very quickly realized after we set ourselves up that the three key elements, science, or engineering, politics, and client base have to be followed together. If we come up with a great product and we create a great engineering solution, but in 10 years' time we've got a fantastic production facility in space, but we've got nobody to sell it to, we're going to go bust in about 5 minutes. If we don't have supportive legal regimes, policy regimes at the national level, or we have significant global opposition within the UN or from other major spacefaring or non-spacefaring states, we have no concept, we have no business, even if we've got a great engineering solution. And lastly, obviously, we need an engineering solution to have a business, otherwise we have no product and we go bust. All of those result in us going bust, which we're trying not to do. So, why are we here? Where did this idea come from? Planetary Resources, I think, is very much part of a wave that hit the west coast of the US and has kind of spread out globally of this sweet spot between advances in some key technologies and a massive crash in cost. We come out of the same flavor of SpaceX, of other companies like that, where the applicability of a series of existing technologies in a new sector and then research and R&D on some specific realities for us, mining an asteroid in microgravity, have allowed new ideas and new companies to become a technical possibility, whereas 10 years ago, 15 years ago, unless you were starting with $1 billion, it wasn't really a possible reality. So we see our role really as expanding the economic sphere of humanity into space. As I'll talk a bit about later, we're a boring business in an exciting environment. We are basically a mining company, an oil company, whatever you want to call it. Our long-term plan is to become a very non-exciting company of producing a very simple resource which we then sell to others. And I'll talk a bit about that kind of ground-based part of the value chain in a minute. But what that enables is a potential growth in a sector which can explode. and what people can use, what we're trying to put forward in terms of resources, is incredibly exciting. So space, I don't have to preach to this audience, I'm sure, but space is a key part of our future. Indeed, it's a key part of our current lives. In terms of everything from transportation to communications to credit card transactions to GPS-based precision agriculture is really critical. What we are going to do in space in terms of potential exploration, looking at long-term missions to Mars, looking at refueling of existing assets, looking at how everybody's going to decide that Tahiti isn't so interesting, but everybody want to go stay at Bob Bigelow's hotel, is a whole new facet of human endeavour and human engagement, both in services that are looking back to Earth, but also in terms of making space an environment where we carry out new and exciting things. Why do resources matter? These resources are going to be the things that make all of that possible. Planetary Resources is focused on two key areas. Firstly, as kind of a subsidiary business, we're looking at metals and things like platinum-based metals, some base metals, but our real key business is the extraction of water. Water for three main reasons, in order of priority, lowest to highest. Firstly, the provision of drinking water. The cost, I think, of a kilo of water currently launched from Earth and ISS is between $40,000 and $50,000 a kilo. And so we're looking at how we can bring water extracted from asteroids at a lower price point than that. Second is water as a radiation shielding. Currently we haven't yet discovered a way to not have really heavy things that you have to send up to space at a great launch cost as radiation. So looking at systems and habitats where drinking water and radiation shielding is combined into one system is something that we're looking at. But lastly, and most importantly, our key business is looking at the extraction of water for its division into hydrogen and oxygen as a fuel source. Whether that's satellite refueling, whether it's refueling of upper stages of rockets, or whether it's looking at fuel for long distance to Mars or potential human habitation, we are planning to be, hopefully on the road to be, basically the universe's gas station. In terms of what we're targeting, we are mainly focusing on asteroids for a variety of different reasons. You'll hear my colleague Kyle from iSpace talk about the lunar environment. As a lawyer, that always makes me nervous. But we are focusing on carbonaceous asteroids. As I'm sure I don't have to, again, tell this environment, the knowledge of what we have about asteroids is still, I think, generously could be said, a work in progress. Much of what we do know and what we don't know kind of stops at the point of what we're going to find on asteroids. For us, if you look at kind of what are we doing, how are we going, we're adding up some very simple technologies that already exist. We know how to launch, we know how to get to an asteroid, we know how to orbit an asteroid, we know how to survey an asteroid, we know how to rendezvous with an asteroid, what extraction and microgravity looks like, and then kind of the later stages of the process, production, storage, scalability, delivery, are new ideas, but a lot of it is based on technology which already exists. So for us, perhaps the key thing about asteroids that when we look at how we analyse which asteroids we might go to in different periods, there's several key things that are important to us. First of all is the orbital period. If it's going to come back in 300 years, that doesn't really do us any good. So we're looking at asteroids which have a reasonably short rate of return, so that they become a multiple-time commercially exploitable resource. The reality of where we are now is our next big mission, which will be going off in 2020, 2021, we'll be looking at specific rendezvous missions with specific asteroids and looking at what specific conditions we find on them. If, for example, we're trying to extract water, and for us, again, perhaps a little different from some of our planetary colleagues, we think that the form we're going to find water most likely in an asteroid is hydrated minerals. So we're really looking at what our temperature delta is to extract that, what other volatiles might be there, how's that going to look. But each of those asteroids is going to be different. If we need to change the temperature in order to liberate water or liberate oxygen and hydrogen from hydrated minerals by 5 degrees or by 500 degrees, that's a very different conversation and a very different technical reality. So for us, while there are a lot of asteroids and there's a big catalogue, what we can access it, when we can access it, how it becomes a useful, commercially exploitable resource, and then also how we start talking about how that relates to our delivery to a client, are some of the kind of things that we think about when we look at our targets and we refine specific parts of our technology for a specific target. So in terms of our kind of focus areas as a company, deep space autonomous rendezvous, 3D printing, our concept on the metals business, and we work with companies such as Made in Space and other kind of 3D printing companies that are looking at how you can start setting up a stable manufacturing facility in space using these kinds of raw materials. It's a key part of how we see us interacting with other parts of the value chain. Sensors, distributed computing, and obviously at this point a lot of experimental work on specific water liberation, extraction, etc., etc. So that's kind of a bit of a quick and dirty overview of us, what we're doing and how. What I thought might be a little bit of a different perspective to give you is how we see ourselves relating to traditional mining. What have we learned? What was true, what was not true? Our company was founded by basically engineers from JPL. We started off very much as a space company. When I joined, and I think when as we continue to grow, we realized pretty quickly we're not a space company. We're a mining company that happens to operate in space. From the technology side, our reality of operating in a microgravity environment means that a lot of the technologies that the traditional mining industry uses in terms of extraction and processing aren't necessarily going to be useful to us, especially when we're focusing on water. But what we realized very quickly was that the nature of our company and the nature of our business is key. Process, mining process. How do you get it from the mine to your client? What does that look like? Where's it best? Is it best to process next to the source? Is it best to process away from the source by your client? So these are some of the issues that we're considering. Risk. I walked into a big mining firm and they said, $400 to $500 million, small money. 15 years, not a lot of time. Turning from prospecting into exploitation, 2 to 4% of everything that they prospect would they exploit? That sounds like my day. If you walk into a space agency and say, there's a 2 to 4% chance we're actually going to get where we're going and achieve what we want, you're going to be thrown out in your ear pretty quickly. I was talking to a big space company in terms of venture capital, like, oh yeah, 5 years, long time, long investment period. For us, 10, 15, 20 years is a realistic period, which when you're building a mine in Congo, dropping a well in the deep sea, these are kind of things that make sense. Financing. We've got an incredibly heavy capex up front. We need a lot of money to get over our first hurdles. Again, very like the mining sector. If you're going to set up a copper mine or a gold mine, you need a lot of money before you're going to get a dollar coming back. And lastly, in terms of standards, how do we make people believe that we're not just some guys who have a great idea and are going to tell you it's going to be fine? Looking at how you start setting data standards for the credibility, quality, size of resources, reserves. When we look at things like the JORC standard, the Joint Ore Reserves Committee of Australia, and a few other global standards, there's a lot of parallels that we see in our business. So, to talk briefly about how we fit, where we go, as I said, we're a more product provision service. We will fill your car with gas, do what you want, go where you want, whether you're running a generator or whatever. However, what that engenders is various different pieces led down the chain. Firstly, you're looking at associated technologies. So I have a lot of big space companies who sit in my office and go, oh, we're thinking about building some kind of transport system. Would we be an interesting conversation about, are we sort of fueling them? Are they transporting our fuel? If there are people that are using our fuel, are they going to need transport? All of those associated industries are going to be enabled by the production of those raw materials. After that, you've got the people who are actually using it. The key problem of us engaging in space is basically we have a bottleneck on the flow of resource. Right now, launch $40 to $60 million if you're lucky, and even what you can put up there is limited in size. Working with a 3D printing company that I think Made in Space is saying that they can make things 80 times their own size of their printers. And also, again, if you've got this flow, what ideas are going to engender? When DARPA set up the internet, I'm sure they didn't imagine that somebody was going to have, an Amazon drone delivering you coffee. So I think what we see our role is that we are going to be able, us and the other companies in the sector, are going to be a game changer in terms of what other people can interestingly do when they have when the fuel and the resource block is removed. So lastly, again, just to talk a little bit about what the international context looks like, I think you're going to hear a bit more of this from some of my colleagues from the Hague Resources Working Group and the Government of Luxembourg. But for us, this is a really key piece of our business. If the policy and legal framework doesn't work, we're always going to run into hurdles at best, more likely into walls at speed. We're very happy that both Luxembourg and the United States have passed national legislation on space resources extraction, specifically looking at the concept of property rights and ownership of resources. Obviously, in space, you can't own asteroids, you can't own planets, you can't own territory. So for us, the codification of understanding how we maintain our rights to access and exploit these resources has been really key. Perhaps to make a simple parallel, we see it very much like fish. When you sail your boat out into the middle of the Atlantic and you pull out a whole ton of mackerel, you own the fish. You're not claiming that you own the Atlantic. For us, the US and the Luxembourg law have allowed us to start building a similar principle up in terms of exploitation. In the future, we're going to see, I think, future national laws, Japan, UAE, I believe that China is also starting to put a lot of thinking into these kind of ideas, and we're going to see more coming onto the table. The importance, I think, of those, though, is not to forget that this is a global business. This is a global endeavour. We work within the UN context and with various processes that are looking to feed into future development at the UN. And I think we're also going to see interest from regional bodies, whether that's ASEAN, or the EU, or the Organization of American States, who are going to start looking at how this harmonizes. So the importance of harmonization is really key. If we don't all work together and all the pieces don't fit, whether that's business, whether that's legal, whether that's country, whether that's UN, the concept is going to struggle to be overall successful and an enabling force. So I know I'm a little over time, so quick conclusions. As I said, what I'd like to take away from my presentation is don't think we're so exciting and special. We're a traditional business in a non-traditional environment. We're an enabler. We believe that we're going to be a game changer. And both our technology, with some key exceptions, and also our policy and our business case are in many ways a Frankenstein reality of combining a lot of different pieces of things that already exist into a new and exciting direction that allows us to hopefully do very interesting things. So thanks a lot, and I will be around if you have any questions.
Thank you very much, Ben. I'm going to call your friend and mine now up to the podium, Kyle Asiana from iSpace, recently moved to Luxembourg. What's going on in Luxembourg? Really interested to find out. And also interesting to hear about iSpace and what you're doing with the Google Lunar X Prize. So, Kyle.